if you zoom into this one, it's fuzzy. Here it stays sharp. So this is a vector, this is a bitmap. This is I'm going to delete this one. So here now I think the FreeCAD powered users will throw lightning at me because I'm going to do some 3D stuff in a 2D program. I'm going to make a box, which would maybe much easier in FreeCAD, but for me it's easier in Inkscape. I've always been doing this in Inkscape because I like it better this way. So so this is a drawing of an Arduino with the measures on it. You could also measure this with a lineal, a ruler, if you want to in practice. But I think this is the easy way. And a fun thing about Inkscape is it uses for its boxes here, for its value boxes, you can put mathematics in there. So for example, now I want to put this Arduino on real size, and I know, so this is 1/1000th of an inch, so I'm going to draw a small rectangle from here to here, and this says it's 2.7 inch. So what I'm going to do now is I'm going to say the width of this box is 84 blah blah blah. So I'm going to copy this value, copy, Control C, and now I'm going to take everything and I'm going to divide this by this value. Then I'm going to lock it, of course. By this value, I'm going to divide it by 2.54 because these values are in inches, and I'm going to multiply it with 2.7. I just put my everything that I would use in my calculator in there, and I made some mistake because that's probably dividing by. So I'm going to divide this by that value, and now it's 1 millimeter big. I'm just going to ignore the lines for now. I'm going to do this times this 2.2. Okay, I'm getting stuck here. It's too much maths in one thing. I'm going to say 2.7 inch. How much millimeter is this? I'm going to cheat a little bit. My calculator. 2.7 times 2.54 millimeters. So 68 millimeters. So this piece should be 68 millimeters now. So I'm going to take everything, I'm going to divide it by the length it was before. Oh no. 84. And I'm going to multiply it by the number in the calculator was 64. Oof. And now I have the actual size of my Arduino. So you can just put your formulas in there and you don't have to calculate everything in your head. I think this is a really handy feature in the Arduino. Not in the Arduino, in Inkscape. This is grouped. I'm going to ungroup it. I'm going to get rid of all the line measures now. Everything sticking out. get rid of it. Okay, and now I have like the size of the Arduino as it is, and I say I'm going to make a box around it of this size, but I'll add some little space. And the tricky part is now this is our bottom plate. What I like to do is I will use layers, because now if I put these together, I will often click this select the wrong one, and it will be annoying. So if I go to my layers menu, I have just the layers menu in itself, and I can put it and it appears here. I can add a layer here. I'll call this Arduino. I'll put this one, I cut it, go to my other layer, and just, if I do Control V, it will paste, but relative to the mouse cursor. If I do Alt Control V, it will paste in place. So if I go to Edit, you see paste in place, and it will paste to the same place where it was, where you cut it. Now if I lock it here, this cannot be moved, cannot be selected, and this is okay. I'll move this layer to the bottom, and here I can now go the lazy route. I can just do it on site, or I can draw it with measures, and I can take exact measures here, but I'll go the lazy route and just do it on site. Now I know the wood I'm going to use in the laser cutter is 3mm thick. This is something I keep in the back of my mind. I want my Arduino box to be how much is this? 4 centimeter high. So I will duplicate this object, Control D. So edit, duplicate, and you see always on the right you have the quick button. So Control D, and I will say the height here is 25mm. I will just snap it against it for now. I will duplicate it, and I'll snap it to here. And now for the other sides, I will also duplicate this, and now the width will become 25. And this is not in place completely. I'll select everything, Control A, and I'll give it a stroke because it's a little bit difficult to see. If I'm going too fast, please tell me, but I think it's okay. If people are having Inkscape on their computer, they can maybe follow me, just making a random box, and then I will put stops and we can try it. You would rather look?
Sorry, I'm already lost.
Sorry?
I'm already lost.
Okay, then I was too fast.
Divide by, yes, wait.
Okay. So what did I? Okay, the reason was sometimes you copy an image from the internet. I will do that step again, just somewhere outside. I downloaded the SVG from this site, but it's in mils, and a mil is like some electronics unit. But if I would search for it,
you wanted it to put it in millimeters, so
Arduino dimensions millimeter. Well, I could use this picture too. And here it says this you see the distance is 50.8 millimeters. I copy the image. I will paste it now. So here is my Arduino. And now this is less accurate because of course it's a bitmap, but I will draw a rectangle on top of it. I will try to approximate the size. And this should be 50.8 millimeters. Yes? So if I take this one, it's now 60 millimeters. If I divide it by 60 and multiply it with 50, it comes to the right size.
Yeah.
So I know now how much I must scale it. So now I will take the whole picture with it, and together I will divide them by 50, but I will lock it because it needs to stay in dimensions, in proportion. Divide by 60 and multiply with 50. And now if we check, this one has become 50 point. We didn't take the exact numbers. It was just a quick example. But now you see this one is the right size, and now I know the rest of the image is also the right size. Now I can work around this image as my model to draw the rest. Did you get it? Okay. I just took this as an example, but you can, if you want to make your box around whatever design, if this is a Raspberry Pi, you will have to take the dimensions of a Raspberry Pi. If you have your own custom electronics project, you can just take your calipers and measure it yourself. But you need those dimensions because you need to know the size of your box.
Take a ruler and all.
Yes, you can take a ruler and that, yeah. Okay, so now that I'm here, I'm still okay. Waiting.
How do you zoom?
Alsjeblieft.
How do you zoom?
Control scroll wheel.
No, that didn't move the first time.
Sorry?
No, I was looking for the word for calipers.
Calipers, yes. Everybody is along? Kai?
Not really, but
Not really.
to continue.
Okay. So now the next thing you need to know is you will have to add some grooves, so a way to connect the walls against the bottom. Because if you just glue it against the side like this, it will not be very strong. So what do they usually make? One typical technique is they make teeth and grooves, and what I usually do is make them symmetric, and I make an odd number. So one is too little, but I mean 3 or 5, or if it's a big part, 7 or 9 or something, an odd number of grooves. So what I do now is I'm going to pull these up. If I hold control, I'm constrained in one dimension, so I cannot go left and right. So I'm just going to pull them apart a little bit, that they're not together. So these are my 4 walls and my floor plate. Now I'm going to duplicate these again, and I already told you my wood is 3 millimeters thick, so I'm going to make this one, unlock it here, wide, 3 millimeters only. No, not 3000, 3 millimeters. And I'm going to snap it against this one. I'm going to duplicate it. Wait, I'm not going to do this yet. I'm going to do the height divided by 5. I'm going to duplicate it. I'm going to take 2 more, duplicate them. And you see I have 5 of these now here. I'm going to select these 5. I'm going to duplicate them to here, to here, and to here. So now I have all the teeth and grooves, and now I'm going to make a decision. So I'm going to hold him, I'm going to keep him here, so I'm going to remove him here, delete. I'm going to delete him here, I'm going to zigzag. So I'm going to like this. Like this. Put the same here. Now I'm going to repeat the same at the top and bottom. So the height now is 3 millimeters. The width is this also divided by 5, or I could take 7. I'm gonna 2, 3, 4, 5, 6, and 8, 7.
Does it duplicate?
Sorry, Control D. Control D. So if you go to
You don't have the little.
edit, I'll put it on my.
I installed it myself now.
Yes, okay. So to show me the keys, but I think it's too big. It takes a lot of screen real estate. That's why I thought not to use it. But okay. But now we have like a tricky part because we have the corners here. So I'm just gonna extend these a little bit so they go to the edge. Yes. Oh wait. First I'm going to duplicate them to this line. Duplicate, take it up here. Duplicate, take it down here. And duplicate, take it down. Not too much. I typically have the habit of having my floor plate the biggest, so with the most teeth, and then have the pieces on the outside going on the walls. But that's my habit. But it's not set in stone. So I'm gonna lengthen these two. Here doesn't do it, so I'm going to duplicate this one to here. Okay, so same trick. I'm going to delete 1, 2, 3, 4, and here I'm going to remove the ones in the middle. So now we have the connections between the floor and the 4 walls. Yes? Now we still need a connection between this and this. That's the next step we're going to do. But first, what are we going to do? We're going to select all the elements that belong together. I'm going to do path union. And now it sticks them all together. And you have one piece. So let's see what path union is. Control plus plus. So control plus. So I select them all. Control plus. I select them all. Control plus. Select them all. Control plus. Select them all. Control plus. Now what I usually do is, for the sake of not making any mistakes, I'm going to make a duplicate just because I'm going to turn it around. If I press my control button, I rotate per 15 degrees, and that's easy to have like a clean, sharp angle. Okay. This is the big one, yeah. Okay. So here it's only a small part, so I'll just like take a 3-part thingy, and now I have the issue that of course my teeth are too long, so I'll just draw a new one. Go from one corner to the other corner, and it snaps, and the height must be 3. And now I have this measure again. I'll divide it by 3. Control D. And because I'm working symmetrical, actually this one and this one, oh, my screen is skewed, is it there too? Yes, it looks like it's much shorter. So actually, this one and the top one are the same, so I'll only make one for now, and then duplicate it at the end. And here I now have to make a choice. It's my choice, I can do whatever I want, but I will keep them symmetrical again, so like this, and now remove this one here, and this one here too. I'll do the same again, Control plus, Control plus. I don't like this. Is this the same? Okay, this is like very odd. Okay, so and now I'm gonna, so this is the same on the other side, so I'm gonna move this one here. And this one can go away. So is everybody still following the story until now?
Sorry, maybe something I missed. How do you confirm that they snapped? Like if you...
Okay, so
It kind of does that, but not always.
so you have snapping on. For me, it's here in the right, snapping. A whole line with all different snap settings.
Okay.
And so you have snapping on off, and then you have snap to bounding. This one is on for me. And snap to nodes, so you can also have the snap to nodes. So these are all snap settings. And if you turn on the right snappings, it will snap to the right setting. You can also have it snap to the center of a rectangle if you want that. I'm already going to give you a small sneak preview. We're going to have a problem here for this USB port because it will be a hole just where the tooth is, but we're going to fix that in a moment. Is everybody okay? Guys still busy? Okay, take your time.
Yeah, but you continue.
Okay, so now we have the top part. You can do just the same, but of course then you can never open it again if you glue it. So you could also make like a lid, just a bigger box, 3 millimeters on each side, and then close it. We can just in a moment, if we have time left, we can also look to make like a hinge, a box that I can open and shut with like two, I can click stuck, but we're going to look into that in a moment. So this is what we have now. And next thing we have to do is draw holes for the openings, of course, because you have to be able to put in your USB port and your power cable and your webcam or your sensors or whatever you need to add to it. So now we have to define the holes. Here I have them visually on this place, the USB jack, and here I downloaded this from the internet too. This is the height of these ports is 12.5 millimeters. So I'm going to make an opening of 13 millimeters, and starting from the bottom of the plate. So what I'm going to do now is, so I'm going to draw this rectangle, and I'm going to make it a little bit bigger than the opening because I know I'm just drawing it with the rough hand, so it can be a little bit offset. And how high is it? 12.5, so I'm going to make it like 14 millimeters. So and now I know where is the bottom of the plate. Is this here or is it here? This one?
No.
This one. Yes, indeed. This is going to the ground, but this is where the Arduino will be standing. So this must line up with that one, but also line up. I'll make it a little bit bigger because it's too.
You use grids, no?
Sorry?
Why not using grids?
Could use grids. That's, yeah. And now I'm gonna put it here. And you see what will happen now if I cut out this piece. This tooth will fall off.
Yeah.
So I'm gonna take this one, take this one. I know it's control minus, but if you go to path and you say difference, no, cut, difference here, control minus. This doesn't make sense. This is going to be a problem if you cut this out. So how am I going to solve this? Well, I'm going to undo it first, but I'm going to leave this one here. And now I'm going to move, because we're no longer symmetrical already because there's a hole on this side. I'm going to just move this one with control pressed in, out, and I'm going to make a small dent here and maybe make this one a little bit bigger. So, and it's again we have that support again. So now I'm going to take a guide from the top ruler and just snap it in here, and snap some guides here just to make sure we're on the right spot. And I'm going to do the same. I'm going to move these nodes with control again, move them up so they snap into here. And now I'm going to draw this thingy here. I'm going to just put it in the corner here and take it down until it snaps here. Could you follow this?
Yeah. Minus.
And now it's control minus. Path difference. Okay. Of course I need to take two. Control minus. And this line I'm going to remove these nodes. Sometimes this kind of stuff happens, so I'm just going to select the line, click in the middle, and say it's a straight line. I think there's a, if you do control delete, it will automatically be a straight line, but I don't know for sure. Anyway, now we don't have the problem anymore of this port falling off. This port, so now I'm going to do control minus again, and now we have like a nice solution for this one. I don't need these lines anymore. If I hover over them, certain moment they become red. Do you see this? Now I do delete, and I can delete them. Wait, gone. Okay, so now we have our opening for the USB port. Now we need the same for the power jack. For the sake of fun, we'll just make a round hole a little bit higher, and assume that it will not give any problems. So again, you go to your design and you see what size it is. It's 12.5 high, but I don't have the dimensions. Normally you have the dimensions, you measure it. So let's say it's 4 millimeters. Again, if I want to have a perfect circle, I do control, and then it goes in doubles. So it's 1 by 2 or 1 by 1. So it's constraining better. And now I can put my radius, or if I just select as an object my diameter, and I lock it here, and I say it's 5 millimeters because my hole is 4. I'm gonna, not you. I'm gonna put you in the middle. I know that I know it's the height. It was 12.5 millimeters, so I'm gonna just fantasize it now. Control minus, and I have my hole. So now I have the holes on this side. This one can say the same. If I would need like an opening in the bottom to make cooling or something, you can just add the holes now. If I need a connector here for these pins, or a connector here for these pins, I can add them now, but I won't add any more pins because it's just the same. And now we can just put it together to try if it fits. this seems to fit, this seems to fit, this seems to fit, and this seems to fit. Okay, so this looks okay. So next thing we'll have to do is now create like a top, a lid. And this is one we want to make go open like this. So what will we need? On the two sides, I'm going to first sketch it a little bit. I'm going to make something like this here, something like this here, with a hole in the middle. The hole in the middle. Yes, and then on the lid, I will make the lid with two pieces sticking out that fit in the holes. Yeah? So last thing we will need is in the front here an opening so it can snap into it. Yes? So here we will add a small thingy with a hole, and here we will just add a very small bump. I mean like a millimeter or something, just enough so the wood can fly and it clicks in. That's the concept. Do you understand it? Now let's do it the clean way. So I'm going to delete all my sketches. So first thing we need is like, I'm going to draw a rectangle. I know my wood is 3 millimeters long, and I'm going to draw a circle on top here. Right? No. So I'm going to make these the same size. So with 12, and this one also with 12. Now I can, with my control button, I can stick to only half a circle, but I'll take the other half. No, not like, I don't want to. I'm just gonna flip it vertically, so I can, it's the V, object path transform, transform, where's the object? Flip vertical, so I'm gonna flip it vertical. I'm going to put it on top. I don't know if you have noticed this, so if you have a circle, now there's no line in the bottom here. If I move my mouse outside, there's a line. Inside there's no line. Because on the outside it makes pizza points. If you're inside, it makes an arc. This is like a detail. So I'm going to put it together now, and it doesn't snap. Why doesn't it snap? Okay, it doesn't snap. How strange. Add some more snapping points. It doesn't want to snap. Sorry? Ah. So I'm gonna align them now. Just Shift Control A, align. So if you go to Object, Align and Distribute here, I'm gonna just line them like this. And before I close it, I will first duplicate this one, make it a full circle, and have it like a radius of 3. So because this is the hole we're going to make, so now I'm going to put these two together, Control plus again. And now we're going to have to think a little bit. How high will this have? Will this need to be? for it to function, because there, if this turns, the piece of wood that sticks out here must be able to move under here. So this part must be here too. Yes? So now I'm going to move all this. No. Down a little bit. It's plenty for the moment. This is really dirty cut because I'm not measuring anything. I mean, it's just lazy people cut. And I deliberately did it this way because it's just the opposite of parametric and having everything constrained and perfectly right. This is just with the fat finger, like they say. It's also possible because in reality I will also always measure my stuff, but this is now just in purpose doing it the other way around. So I'm going to duplicate it again. Vertical flip. I'm going to move it here. Ali, something's wrong with my thingy. So I'm going to add these two together, and I'm going to actually duplicate it because I'm not sure they're exactly the same. I duplicated and flipped it vertically. All my snappings are gone. I broke my system. Okay. So I think this is too high actually. But so now we're gonna draw our line, our 3 millimeter line, to have just an idea of where it should more or less be. So here is where we will want the plate to end up. And now if you click it, you see these nodes change shape, and in the middle you have your rotation point. Yeah, I will move this to the middle of my hole and open it up. I want it to go so high, not higher. So as you see, I have like too much space left over. So I'm going to move this so much. Move this the same distance.
Should the hinge not be outside the box?
Sorry?
The hinge not be outside the box?
That's also a way you can do it.
Yes, there's different options.
Like this as well.
No, I know, but
But
if
if
you're
you
going
put it
below
outside the
the
box, it's easier to have it. It's mechanically easy, but
Yes, but okay, then you would have to make your design angled. Yes, it's also an option. It has some advantages because then you have your stop, and it can't flap over, because now I will make my stop here by adding an angle here, and I will actually just make it like this, my stop. Start here, go up a little bit. I will flatten this a little bit, but also round this a little bit. And now I will add these two. And now the lid cannot go over. It's a small stop. It's probably not the perfect solution, but it's a solution that I have used and it works. So let's duplicate it again, flip vertically, move it to here. Now we have two the same things. And next thing we want to do is create the lid. So I'm going to remove my helping line, my lines again. So I could have drawn my box here in the beginning, my lid, but I'm going to do it now. Oh, come on. Okay. So this is the shape of my lid. I'm going to pull it to the top. And now I'm going to move this just to the right place here, so I know where I have to be with my rectangle. That's 3 millimeters, 6 millimeters wide. And it has to stick out 6 millimeters too, so plus 6 millimeters. And I'm going to now align them according to the last selected one. So this means this will be the reference point, and I will center them. So now this is in the middle. And I will add a little bit of overlap here, 3 millimeters, so it comes together with this one. Now I join them together. And this is this part of the lid, okay? Now I'm going to add a small 1 millimeter wide, 25 millimeter thick. 25 millimeter is the important part. Okay, I'm going to leave it like this for now. I'm going to duplicate it. Here it has to be, how high must it be? 3 millimeters because of the thickness. It could even be a little bit more, but I'll take 3. I want to align it. Control plus. No, not correct.
No, first you have to draw the box around it.
Yes, so now I will extend these nodes to over it. Yes. Control minus. I have an opening, and this will fit inside. You trial and error. You can see which will be a good measure. Is this too little or is it too much? But maybe it could be a little bit more.
You can still sand it.
Sorry? You can sand it. Yes. Yes. But I mean, it's only MDF, so you try it. This is. I like to make 2-3 versions, and then the last one is the good one.
So, what do you use from MDF or plywood?
MDF. So now we have like the sides, the front, the back. I think this will be an issue, so I'll actually make this a little bit shorter. And I will make these a little bit smaller too, these nodes. So they fit in better. And let's see if I have everything now. So I have my lid. Actually, my lid will now not be very nice in the sense that there will be a split between this one and this one. So I will have to add some space here. Three millimeters. I aligned these two. I'm gonna union them, and I think this should work. Oh, what happened here? Apparently it's not overlapping, so I'll make it a little bit bigger for now. Okay, now I think we're there. I think now we have the design of the bottom, the front, the back, the two sides, the lid. Okay, I'm gonna remove my constraints. I'm gonna save this as your desktop, bad habit, Arduino SFD, and we're gonna open the. Is the Glowforge running?
Yes.
Not yet.
Oh, yes.
Yes.
Turned on.
Okay, great.
Half an hour ago.
So I'm gonna go to the Glowforge application. That's our laser cutter. Oh, I'm already logged in. Okay, so I'm going to create a new design by uploading from a file. It was on my desktop. Okay, now I'm going to get rid of these parts because that's the bitmap. What's this? Of course, all these Arduino POS. Yes, I will remove the Arduino from the original because it's also SVG and it wants to print all this stuff. So I'm going to remove the layer, the Arduino layer. Just going to remove it. Save now. This one. Save. Going back to my browser now. I'm going to go back to delete this one. To upload a file. And this looks much better. There's already a piece of wood on. What a surface. And this, we're going to cut this. This is plywood.
The metal still stick together?
Yes, it will cut twice. So normally I would take them apart in the design.
If you want to be nice, it's important to pull them apart, but it's just for the.
Yes.
If you use it together, that's just not.
Yes, you could that. But then you have to move double lines. I think there is an Inkscape script that does this, but I haven't looked into it yet. So now I'm going to print it.
How long does it take?
It's calculating. A few minutes, I think. 2 minutes or so. This is like the big advantage over 3D printing. If you want to 3D print something like this, it takes like 4 hours.
I'll go in 2 minutes.
Yeah, it's 2 minutes. Normally, now I say to my daughter, go push the button. And then she goes, bang.
But you have to glue it together and wait for the glue.
Yes, that's right. But you can already try it. You can use duct tape.